Okay. Well, first things first with this one. It's definitely not quadratic because we have a cube term. Okay. That doesn't change what we do initially. The goal is still the same as it is for all of these other ones that we've done. Okay. Going back to here. Set it equal to 0, factor, find those zeros from the factored form like we did with this. Set it equal to 0, factor, find the zeros from that factored form. Set it equal to 0, factor, find the zeros from that factored form. Sorry, where were we? Uh-oh. Here. So what are we going to do? We're going to set it equal to 0. We're going to attempt to factor it. And we're going to find the zeros from that factored form. To set it equal to 0, both of these terms have to come to the other side. It'll be x cubed plus 2x squared minus 25x minus 50 equals 0. And you're like, factor? How do I factor that? You factor by grouping. So we look at the first two, and it's not, how do we know? Let's go over it again. How do we know we can factor, at least attempt to factor by grouping? We have 4 terms. The degrees are in descending order. These are separated by 1, and these are separated by 1 degree. So this is technically x to the 0 power, right? Okay, x to the first. We can, the separation here in the degree is the same as the separation here. So I can try this. I'm going to try to take these two groups and factor. Look for the common factor here. That would be x squared. So I have x plus 2. Now, in fact, if this is going to work, I'm no longer looking for the common factor. Well, it has to be a common factor. I'm not looking for the greatest common factor. I'm just trying to get this to give me x plus 2 when I'm done. So if it's going to say, if this binomial is going to be x plus 2, then I need to take out a negative 25. I have to. It has to work that way. And cross your fingers, hopefully when I divide this by negative 25, there'll be a plus 2. And it does. It works out. The math works here. So I have this result from my grouping. So I take the x squared and the minus 25 and I put them together. I take the x plus 2 as that factor. I write it with it. Now, these are 2 factors of our original polynomial. Okay, don't get me wrong. They're not linear factors because this is x squared. So if you were thinking, and this is why we have to be careful with the terminology we use, if you're like, well, the 0 must be 25 because it's always the opposite of whatever that number is, that's not true. Okay? You could go further because I'm crossing my fingers and my toes. Okay? Hopefully you recognize that this is the difference of squares. And the difference of squares factors into conjugates. I can't begin to tell you, even though I've already begun to tell you for the last 2.5 weeks, how much the difference of squares and your factoring of that plays a role in pre-calc. Tons. Tons. Okay? You got to have a trained eye for this. The difference, subtraction of 2 squares. These are both perfect squares. Factors into conjugates, one with a plus, one with a minus. Now these are the linear factors, so we know that the 0 from here is negative 5, the 0 from here is positive 5, and the 0 from here is negative 2. Here are my 3 solutions for x. Yes?
If we were to take the square root of x squared minus 25, could you just put x equals...
plus or minus 5?
Yeah.
Yes. Yes. That's a good question. Because going back to the way that we originally did this, if these factors have a product of 0, then this should equal 0. right? That's what you were doing. You're taking the factor and setting it equal to 0. It's totally fine. Okay. I'm just trying again. I'm trying to set you up for pre-calc, and there's something called the fundamental theorem of algebra, which we'll save for then. But basically, because the degree of this function is 3, it should have 3 linear factors. So I'm in the habit of creating those linear factors to prove that theorem. Okay, does that make sense?
Yeah.
But there's nothing wrong with this, right? If the question is what's the solution, you still get positive and negative 5 from solving that, and you get the negative 2 from there. So no problem.